Welcome to this tutorial on finding and verifying inverses. We will look at two problems here. First problem is pictured on the board. Well, the first thing we're going to do is translate it into y equals 3x minus 7. And then what we realize is to find the inverse, we switch x and y. That's the key to doing the inverse. So we will write x equals 3y minus 7. But now we need to get the y by itself. So we add 7 to both sides, and then we want to divide both sides by 3. Now really we don't want to simplify this a whole lot more than what we see right there. So we're going to leave it as y equals x plus 7 over 3. And more specifically, the inverse of f is that, so we claim. To write the notation properly, we say f minus 1 of x is equal to x plus 7 all over 3. That says the inverse of f is x plus 7 all over 3. Now when verifying inverses, we have to check two things. One of them is we need to see if f of f inverse of x just turns out equal to x. So I want to see this, and I need to see this written up properly, where first we translate it into having these parentheses, f parentheses f minus 1 parentheses x. And now we're going to replace the f minus 1 of x with what the inverse is supposedly equal to, which is x plus 7 all over 3. And this is where the function composition comes into play. Because now, in the original function f, wherever we see an x, we're going to replace it with x plus 7 all over 3. Make sure you cancel things correctly. The first thing that cancels in this problem would be the 3's right here. So we get x plus 7 minus 7. And then the next things to cancel would be the 7's. And that just turns out equal to x. That's what we need to have happen to verify that they are inverses. Now on the other hand, we want to show that it doesn't matter the order in which we take those functions. So we need to show that f inverse of f of x is also equal to x. Well, the first step is we're going to rewrite this as the parentheses, f inverse parentheses f parentheses x. And then we're going to replace f of x with what it's equal to. In this case, that's the 3x minus 7. And now we're going to plug that in place of x in the inverse. So we're going to have 3x minus 7, replacing x in here. Then we still have plus 7 all over 3. What cancels first? Hopefully you can tell that would be the 7's up top. So we'll have 3x over 3, and then 3 over 3 cancels, and we just get x. If they truly are inverses, they typically cancel this way, where it's in the reverse order. All of this is what we would need to see as the solution to a problem. First, you'll show how you came up with the inverse and what the inverse supposedly is. Second, you will show how f of f inverse of x is just equal to x. And third, you will show how f inverse of f of x is also just equal to x. One more example we're going to find the inverse of. First, we replace g of x with a y. First, we replace g of x with a y. Then the key to an inverse, remember, is that we switch the x and the y. From there, we need to get the y by itself. It's one step at a time. So first we will subtract the 1 from both sides. Then we will square both sides to get rid of that annoying square root. But please don't FOIL the left-hand side, because that would make it a whole lot more difficult to verify inverses. Next, we will add 5 to both sides. And last but not least, we will divide the entire equation by 2. So what we end up with is that the y is equal to x minus 1, the quantity squared, plus 5 all over 2. But instead of calling it y, we would need to call it the inverse. So this is going to be g inverse of x. Please make sure you use the correct lettering. That will be an important thing, and it will be something that I look for on a test or a quiz. So now to verify inverses, we need to do 2 things. Make sure you use the correct lettering. One of them is we will analyze g of g inverse of x. First step, rewrite it. Second step, replace g inverse of x with what we claim it is. X minus 1, the quantity squared, plus 5 all over 2. Then, we're plugging that into g. So we go over to the g of x function, and everywhere we see an x, we're going to replace it with what we have in magenta there. So it'll be radical 2. Now we're going to replace the x with all that stuff. So it's x minus 1, the quantity squared, plus 5 all over 2. But be careful because there's more inside that square root. We have a minus 5, and then make it clear where the square root ends, and we have a plus 1 off on the side. And we can extend that a little bit if we want. So now as we simplify, keep your equal signs going. The 2's are the first thing that are going to cancel. You have to make sure you understand what cancels in what order. If you don't cancel in the correct order, points will be deducted. Follow the order of operations. Next, the 5's cancel. Then the square root and the squares cancel. And last, the negative 1 and the plus 1 cancel until we just get x. One other thing needs checked, and that would be, does g inverse of g of x turn out equal to x? Well, first step is we are going to rewrite this. Then, in place of g of x, we'll write what it was equal to. Radical 2x minus 5 plus 1. Now we're plugging that into g inverse of x. So, it's x, which is this thing, square root of 2x minus 5 plus 1. It's x minus 1 squared plus 5 all over 2. So we are kind of plugging it into that magenta thing, and hopefully we see how that works out. First thing that cancels are the 1's. You have to make sure that you cancel things in the correct order. There's only one option following the order of operations. Next, the square and the square root cancel. Next, the 5 and the negative 5 cancel. And finally, the 2's cancel. And again, once you've shown this, you're done. First, use the property of inverses to find the inverse, and that is just that we interchange the x and the y. Then we have to verify that it doesn't matter which order we compose the two functions. They both turn out equal to x. If you do that, that is how you will both find and verify that items are inverse functions.